Assalamualaikum and hi to everyone. My name is Putra Alisa. So today we would like to share about gas chromatography. This is an introduction. Basically, chromatographic analysis is used to separate complex mixtures of compounds. The chromatographic systems have two phases, which are stationary phase and mobile phase. Stationary phase is a fixed in place in a column or a solid surface, while the sample is dissolved in mobile phase such as gas, liquid or supercritical liquid. As the sample passes through the stationary phases, the compound in the mixture will be separated because of the differences in their affinities for the stationary phase and differences in their solution in the mobile phase. Furthermore, for an introduction, gas chromatography, or we call STC, is defined as an analytical technique used for rapid separation and analysis of volatile substances in various samples, including forensic evidence such as drugs and toxins. It can be efficiently coupled with mass spectrometry for accurate identification of molecular composition. Next, for the objective, first, to determine the retention of N-butanol and 2-propanol. Second, to identify the components present in a standard mixture based on the retention time. The third one is to identify the components present in an unknown sample. Lastly, to determine the effect of the temperature on retention and RS.
So next, this is a gas chromatography diagram. This diagram shows the working process of gas chromatography. The sample is first injected into the injector, where it is vaporized before entering the column. The carrier gas then moves the sample through the column as the mobile phase. Inside the column, the components are separated based on their different interaction with the stationary phase. The components with weaker interaction move faster, while components with stronger interaction takes longer times to pass through the column. After separation, the components reach the detector, which detects records the signals to produce the chromatogram. The peaks obtained represent the different components in the sample, and the retention time is compared with standards to identify the compounds present. Next, I will explain the procedure of the experiment. First, the sample handling procedure was carried out. The shrink was rinsed before the sample was filled. The sample was ensured to be free from air bubbles by gently tapping the shrink. The excess sample was then removed using a tissue until the required volume was obtained. Next, the gas chromatography instrument was switched on and set according to the required condition. The initial and final oven temperatures were set at 70 degrees Celsius, while the injection and detector temperatures were maintained at 180 degrees Celsius. The individual component samples were injected first to determine their retention time. After that, the standard mixture was injected, and the components were identified by comparing their retention time with the individual components. Then, the unknown sample was injected to identify the components present in the sample. Finally, the column temperature was adjusted to 100 degrees Celsius, and the oven temperature was increased to 150 degrees Celsius. The standard mixture was injected at this condition to observe the effect of temperature changes on the retention time and resolution of the components.
Hi, my name is Alisha Shazri, and now I will present the result obtained from the gas chromatography analysis. First, let's look at the unknown sample. The chromatogram shows one major peak at a retention time of 5.963 minutes with an error percentage of 99.83%. There are two very small peaks at 2.647 and 2.926 minutes, but their error percentages are less than 0.2%, indicating that there are only trace impurities or background noise. Therefore, the unknown sample mainly consists of one compound. Next is the pure 2-propanol standard. The chromatogram shows a single major peak at 2.709 minutes with an error percentages of 99.98%, confirming that the standard is highly pure. Since this retention time is much shorter than that of the unknown sample, we can conclude that the unknown compound is not 2-propanol. Now, let's look at the pure n-butanol standard. The major peak appeared at 5.961 minutes with an error percentage of 99.82%. This retention time is almost identical to the unknown sample, which has a retention time of 5.963 minutes. The difference is only 0.002 minutes, so we can confidently identify the unknown sample as an n-butanol. For the standard mixture at 70 Celsius, two major peaks were observed. The first peak appeared at 2.675 minutes, representing 2-propanol, while the second peak appeared at 5.816 minutes, representing n-butanol. The two peaks were well separated, showing good chromatographic resolution. When the column temperature was increased to 100 Celsius, the retention time decreased to 2.268 minutes for 2-propanol and 3.275 minutes for n-butanol. This is because increasing the temperature increases the volatility of the compound, allowing them to move through the column more quickly. At 140 Celsius, the retention times further decreased to 1.956 minutes for 2-propanol and 2.237 minutes for n-butanol. Although the analysis became faster, the two peaks moved much closer together, meaning the chromatographic resolution was reduced. Now, let's talk about discussion of our gas chromatography experiment. The aim was to identify an unknown sample by comparing its retention time with known standards. The pure 2-propanol standard had a retention time of 2.709 minutes, while the n-butanol standard had a retention time of 5.961 minutes. The unknown sample showed a major peak at 5.963 minutes, which closely matched the n-butanol standard. Therefore, the unknown sample was identified as n-butanol. We also found that increasing the column temperature from 70 Celsius to 140 Celsius decreased the retention time because the compounds became more volatile and electrolyte faster. In conclusion, gas chromatography is a reliable method for identifying compounds, and column temperature plays an important role in both analysis time and separation efficiency. Thank you.
In conclusion, from this experiment, the retention time can be determined where the TR of n-butanol and 2-propanol is 5.96 minutes and 2.71 minutes respectively. Besides, we can identify the components that is present in the mixture based on the retention time. We can also learn the effect of temperature on the TR and RS. The higher the temperature, the higher the retention time. Hence, RS also increases. For questions, first, state the types of the compounds which are suitable for analysis using gas chromatography. The answer is the type of compounds which are suitable for analysis using gas chromatography are hydrocarbons, halogenated compounds, compounds containing halogens, sulfur or nitrogen, and organic compounds. Second question, why is FID a suitable detector for this analysis? The answer is flame ionization detector FID is a suitable detector for this analysis because FID is used to detect hydrocarbons. Ionization detectors interact with solids eluted from gas chromatography columns to produce a current that varies in proportion to the amount of solid present. It will not detect non-carbon containing compounds. This detector responds to all organic compounds except formic acid, and the response is highest for hydrocarbons. Besides that, the detector is insensitive to H2 or to N2SiCl4SO2 and O2, H2O and NH3. FID requires hydrogen supply and oxygen supply. Lastly, FID adds high bits height sensitivity. The last question, list two factors which can increase the efficiency of a gas chromatography column. The answer is factors that can increase the efficiency of a GC column is by reducing the packing size of column and by lengthening the column. These factors may increase the efficiency of a gas chromatography column.